Okay, and welcome to today's video on molar mass. In this video, you will learn about what molar mass is and how to calculate it. So to start with, let's talk about what is molar mass. And molar mass is the mass of 1 mole of things. Okay, and remember that 1 mole of things, 1 mole is 6.02 times 10 to the 23rd things. And so this is the total mass of all of those things added together. So molar mass is thing dependent, meaning it changes. All right, it absolutely depends on what my thing is that I am measuring. 1 mole of eggs is going to have a very different mass than, say, 1 mole of ants will, okay? Because 1 egg has a different mass than 1 ant. So molar mass is going to be very helpful to us when we think about atoms and molecules and formula units and ions, because all of those things have individual masses also. But for right now, we can just leave it at this definition. So molar mass is the mass of 1 mole of stuff, okay? And let's go back and review just an example that we kind of worked through the other day. So we said that 1 dozen eggs is 12 eggs, all right? And I had to take the mass of 1 egg. And so I go to the balance and I find out that it weighs 67.13 grams. So if I want to know the mass of 12 eggs, okay, which is really saying 1 dozen, then I'm taking 67.13 grams per egg and I multiply that by 12 eggs per dozen, and so I get 805.6 grams per dozen if you do that math. So it's a really simple concept. I'm taking the mass of all of my things. I need to know the mass of each thing, each item. So let's expand that. So now let's say I have a mole of eggs, and a mole of eggs is 6.02 times 10 to the 23rd eggs. Again, 1 egg is 67.13 grams. So I can say 67.13 grams per 1 egg times 6.02 times 10 to the 23rd eggs in 1 mole. All right, so eggs is my unit that cancels out. So when I multiply that, I get 4.04 times 10 to the 25th. And my unit here now is grams per mole, G over MOL for moles. That is, if I had 1 mole of eggs, that's how much all of those eggs would weigh together. Okay? So now we're going to do the same thing, just with smaller things, like atoms and molecules. And so if you have your periodic table, now would be a great time to pull it out. I have one right here. And I'm going to come back to this slide here in just a minute. So have this handy. I'm going to tell you a really important piece of information. So on the periodic table, the mass of 1 atom, we said before, was in AMU. So when I go and look at the mass for each element, that was in AMU, and that's for 1 atom. But now, if I have the mass of 1 mole of atoms, which again is 6.02 times 10 to the 23rd atoms, it's going to be that same number, but in grams. Okay? So let's go back and see what we mean. If I take, just change my color here quick. So if I look at these masses, for each of these individual elements, these are the masses that I'm looking at. Okay? So now this is the molar mass for an element. Okay? So for boron, it's 10.81 grams. For carbon, it's 12.01 grams. And so the good news is that we can just go right to that total mass. We can just look right on the periodic table and find that number of grams. We don't have to multiply it by 1 mole, by 6.02 times 10 to the 23rd, because that has been done for us already. So we can just trust that those numbers are the same, and they're going to be useful for us. So again, if I look at sodium, go back and look at sodium's molar mass. Sodium is 22.99 grams per mole, and iron is 55.85 grams per mole. Okay, so let's work through a couple examples. So, or before we do that, let's talk about how we calculate molar mass. So how do we calculate? So for elements, I just look on the periodic table. And whatever it is on the periodic table is what that molar mass is for the element. For compounds, I need to add the separate molar masses together for all my elements in my compound. Okay, so I have to look at what all my atoms are, find their separate molar masses, and then add them all up. Okay, so let's do a couple examples. So let's say I have the molecule bromine, and I want to find the molar mass of bromine. So 1 mole of bromine molecules. All right, if I go back and look on my periodic table, I know that the mass of bromine is 79.9 grams per mole. But first I have to pay attention to this little 2 right here, because what that means is I have 2 bromine atoms joined together to make a molecule, and then I have 1 mole of all those molecules. So I have 6.02 times 10 to the 23rd molecules. But that's already taken into account when I pull out the 79.9 grams. So I have to multiply that by 2 bromine. Okay? When I multiply that by 2 bromine, I get 159.8 grams per mole. All right? And that is my answer. So that's example 1. I can do another example with water, which has 2 elements in it. And so first, let's show it a little bit different way. So let's list out all of my elements and count how many of each different element there are. So I have 2 hydrogen and 1 oxygen in this compound. And again, I'm going to find the molar mass, so the mass of a mole of water molecules. Again, I look on my periodic table. You should be looking at yours also. And so for hydrogen, it's 1.01 grams per mole, and for oxygen is 15.99 grams per mole. So I'm going to kind of do separate math problems here just to show you what I'm doing. So I'm going to take 2 times 1.01, which is 2.02 grams. Okay, and then 1 times 15.99 is 15.99 grams. But now that's for each of the elements separate. If I want to find the molar mass of the compound, I have to just add them up. So 2.02 plus 15.99 gets me 18.01, and my unit there is grams per mole. Okay, so let's review what that's really saying. So 18.01 grams is 1 mole, which is equal to 6.02 times 10 to the 23rd molecules. Okay, that's what that's telling us, and all those things are equal to each other. Okay, and let's do a third example here with aluminum hydroxide. So I have to count very carefully here because I noticed some parentheses. So a lot of mistakes can be made here at this point. Just pay really close attention. So I'm going to have 1 aluminum, 3 oxygen, because I distribute, right, to everything that's in my parentheses, and I also have 3 hydrogen. So go ahead and pause it. You can look up each of the masses individually and try this one on your own. If you want to keep going, we can do, I'll just write them down here for you too. So 26.98 grams per mole. Oxygen is 15.99 grams per mole. And then again for hydrogen is 1.01 grams per mole. So you get used to these numbers in your head because you use some of the same elements over and over again. So 26.98 grams here. 3 oxygen times 15.99 is 47.97 grams. And then 3 times 1.01 is 3.03 grams. So again, I'll add all those up, and I get 77.98 grams per mole for my final answer. And the only way that I can say that that's grams per mole is because it's the mass of 1 mole. Okay, so 1 mole of that stuff, aluminum hydroxide, weighs 77.98 grams. All right, so go ahead and flip your study guide over and do the rest of those examples on your own. Bring any questions that you have with you back to class, and we'll see you guys later. All right, thanks for watching.